In this question, we are given the outer dimensions of a closed rectangular cardboard, which are 8 cm by 10 cm by 12 cm. And we are also given that the 6 sides of the box are uniformly half centimeter thick. So, the thickness of the box is equal to half centimeter or 0.5 centimeter. We are given that a closed canister in the shape of a right circular cylinder is to be placed inside the box so that it stands upright when the box rests on one of its sides. We have to find out of all such canisters that would fit, what is the outer radius of the canister that occupies the maximum volume. So basically, if this is the base of a rectangular cardboard box, the canister must have the radius equal to the side of the rectangular box. So let's move on to step 2 and understand how to proceed with the solution. Now let's make a two-dimensional diagram. Now if this is the dimensions 8 and this is the dimension 10, and the width or the thickness of the cardboard box is 0.5, then what will be the inner dimension? The inner dimension would be 10 minus 2 times 0.5. This is because the thickness is on both the sides. So the inner dimension will be equal to 7 times 9 times 11. Now there are 3 cases possible. So case 1 can be when the base is equal to 7 times 9 and the height is equal to 11. Case 2 that is possible is when the base will have the dimensions 7 by 11 and the height will be equal to 9. And the last case that is possible would be when the base has dimensions 9 to 11 and the height is equal to 7. Now we will discuss all the 3 cases in step 3. So in case 1, when the base has dimensions 7 by 9 and the height is equal to 7, volume of the cylinder will be equal to pi r square h. Now if the diameter is 7, then the maximum radius will be equal to 7 by 2. Then we can find the volume, which will be given by pi times 7 by 2 times 7 by 2 multiplied by 11. This is equal to 49 times 11 by 4 times pi, which gives us 539 by 4 times pi. Now we have to check if in the other cases the volume is greater or less than this. And in each of the 3 cases, whichever one will give us the maximum volume, that will also give us the radius. So let's move on to case 2. In case 2, the dimensions of the base is equal to 7 by 11 and the height is equal to 9. Then here the maximum radius will be equal to 7 by 2. Then the volume will be equal to pi r square h, which is equal to pi times 7 by 2 times 7 by 2 into 9. Now this is obviously less than 539 by 4 times pi, because previously we had multiplied pi by pi times 7 by 2 times 7 by 2 by 11, and here we are multiplying by 9. So obviously the value in case 2 will be less than 539 by 4. So at the moment, the volume that we got in case 1 is maximum. Now let's proceed to the case 3, where the base has dimensions 9 by 11 and the height is equal to 7. Here the maximum radius will be equal to 9 by 2, and thus the volume will be equal to pi r square h. This is equal to pi times 9 by 2 times 9 by 2 times 7. Now this is greater than 539 pi by 4. And since in case 3 we are getting the maximum volume, we conclude that the outer radius is equal to 9 by 2, which is equal to 4.5, which is the option C.